All right, we've made it to our final lab. This is lab number 13, where we're talking about acids, bases, and pH. The first part of your lab, you're actually going to be creating your very own paper sensors, which is a really cool thing, and it's really easy. Paper sensors were something that I studied in graduate school, and there's a wide variety of them. Oftentimes they change color in order to reveal a certain chemical. So, cabbage is very unique in that there's a color changing compound in here. It's actually what makes the cabbage this purple color. And the compound will change color depending on what pH it's exposed to. So, I guess I won't tell you, but you'll be exploring different solutions, acids and bases, and neutral solutions, and finding out what color this compound will turn when exposed to them. So in order to make the sensor, we're going to be using paper towels, hot water, which you can hear boiling over there, and a cabbage. So the first thing you have to do, you're going to have to cut up some cabbage. You probably actually don't need a whole head of cabbage for the experiment you're doing, so maybe you live with someone or maybe you yourself like to cook cabbage. You'll have leftover for that. And notice as you're cooking it as well, oftentimes people cook red cabbage in vinegar. Notice the color change that happens. If you cook the cabbage in vinegar, a color change will happen. And if you're cleaning during the dishes and the red cabbage ends up in the sink with soap, you'll notice another color change. Maybe you can think back and try to remember that color change if you've ever seen it, because our paper sensors are going to do the same thing. So, we are going to just chop up the cabbage. So based on what we learned in our lab about factors that affect rates of reactions, we know that surface area, increased surface area, increases the amount of the substance that's exposed to its environment, so it can increase reactivity. So that's why we chop up our cabbage, and the smaller the better really, because then the hot water will get to more of the cabbage and be able to infuse more of this color changing compound into the solution. So that's probably good enough. So I'm just going to put it, I have a pan here. You can use anything. You can use a big bowl, you can use a pot, you can use a pan. Just put my cabbage in there, and why not use the end as well? It's just, we're not going to eat it. We're just infusing it for the color. And then the rest of this cabbage you can save and reuse. So, now my water's boiling. So we're basically infusing this color changing compound into hot water just like we would be doing if we're making tea. So we're making an infusion. So I'm going to get the hot water. And I'll just pour it right into my pan with the cabbage. And pour some more hot water into my teacup. And put it down over here. So we're going to just let that infuse for a while. So you may want to get a cover. I'm going to get a cover to cover that up. Okay, so now we have our hot water cabbage infusion going on here. Let's leave that for 5 minutes or so, 5-10 minutes, whatever's convenient for you. It'll only get stronger the longer you steep it. So I'll be right back as soon as the infusion is done, and I'll show you what to do. Okay, so I've let my cabbage steep for about 5 to 10 minutes. And I can see that the color is a really nice, deep, purpley blue. Let me angle this screen down. So you can see that color. It's purplish, bluish. And I'm going to be filtering out the cabbage and pouring the solution into this pan I have here so you can see the color better. But first, I drew the compound on the board, the compound that is in red cabbage. It's called anthocyanin. So there's a whole class of anthocyanidins, which are compounds that change color in plants. The function within a plant is oftentimes to attract pollinators, like bees, that will come to the plant and help to spread the seed. This also can have antioxidant properties, meaning it can scavenge what we call free radicals and reduce stress on the plant. That's still being studied, its role in the plant, but humans eat these plants largely for their antioxidants that we can get from them, which help to prevent oxidative stress and prevent disease, which is one of the reasons why vegetables are so good for us to eat. So the structure you'll see here, again, we're not really getting into structure in this course, but what you see are rings, and these are made up of carbons. So there are 6 carbons. At each of the points there's 1 carbon. In this ring there are 6 carbons. The 2 lines means there's a double bond between 2 carbons. 2 bonds are there. And these other rings are similar in structure to that. We have an oxygen at the top of the middle one. And then these R groups. It's not an element named R. It means it's a functional group, so they can change. So this represents a whole class of compounds. An R group means it could be a functional group that contains carbon, oxygen, hydrogen, nitrogen. And depending on which functional groups are present and where they are, that will change the reactivity of that specific anthocyanin. So regardless, this is the type of compound that we see in red cabbage. You're not going to be asked to draw this on an exam or anything, but I want you to see it and understand what it is that we're looking for. So this has the ability to change color, whether it's in an acidic environment or a basic environment. Okay, so we're going to take our cabbage, and I'm going to get a strainer. And we're going to just pour the liquid into this pan, trying to catch the big pieces. It's working out all right. And the color already looks a little different than the cabbage itself, if you can see that. The cabbage was sort of a purple color, and we have this blue solution that we've made. And what I'm going to do to make our paper sensors is just dip paper towels in the solution and then let them dry. So I'm realizing the last time I made these sensors, I lived at a different apartment, and I think the solution was more of a purple color. So it could be that the water, the well water that I use here, is more basic. That's a hint of what color you're going to see in your sensors. Is more basic than the water I used the last time I made the sensors, because I see it turning blue. So you'll see what shade you end up with. So I'm using paper towels. You can dip the whole thing in all at once and then set it somewhere to dry. I'm just gonna, so like I was saying, I'm just dipping paper towels in this solution that I created by infusing cabbage into hot water. And I'm just going to be setting them on the counter to dry for several hours. It will be better if you have paper towels that do not have patterns on them. I don't know for sure if the ink on here is going to interfere with our measurements. So I'm just ripping off the white part and using that. So just dipping it and setting it out to dry. And we really don't need too much. You're going to be testing several solutions, but you only really need kind of a drop on each sensor. So just showing you what some of these sensors look like. We're going to leave these to dry for however long it takes them to dry, probably several hours. And I'll be back with the rest of the experiment. I'll show you how to use these sensors to test various solutions. And you actually don't need to save this solution for any reason. If you'd like to have some fun, you could put some vinegar in here and watch the color change. Maybe split it into 2 containers, put vinegar in one, put soap in the other, and see what kind of color change you see. Soap is an example of a base, vinegar is an example of an acid. And we'll be back. Okay, I just want to show you, as I was getting rid of my solution, I did do that experiment I mentioned. I put some of it in a jar with soap, You can see it turned this blue color. So that's a hint as to what your bases will look like when you test your solutions in this lab. And then the other bit of solution that was left over, I just poured some of the white vinegar in there that we used earlier in the semester for our experiments. And we got this really nice bright pink color. So you can infer from that the acids are going to turn this anthocyanin pink. So we'll see as we use our sensors if we get the same type of response from those.